When dealing with generator installations and automatic transfer switches, understanding the National Electrical Code, or NEC, requirements is crucial for safety and compliance. If revising an existing 400 amp service that includes two 200 amp main breaker load centers to incorporate a backup generator and an automatic transfer switch, specific considerations must be addressed. Firstly, if the transfer switch lacks internal overload protection and isn't listed as service equipment, overload protection is indeed necessary ahead of the transfer switch. This protection is essential to safeguard the transfer switch from potential short circuit and ground fault conditions. Secondly, NEC Section 700.12 directly addresses this issue, stating that automatic transfer equipment must be provided with overload protection by a circuit breaker or a combination of fuses and the disconnects. This requirement exists because transfer switches themselves are not inherently designed to withstand or interrupt high fault currents that can occur during a short circuit or ground fault. Without overload protection, these fault currents could severely damage the transfer switch, leading to equipment failure, fire hazards, and potential safety risks for personnel. Therefore, the installation of a properly sized circuit breaker or a fuse disconnect combination ahead of the transfer switch is a critical safety measure. Let's delve deeper into the practical aspects of implementing this requirement. When selecting the appropriate overload protection device, such as a circuit breaker or fuses, several factors must be considered. 1. The ampacity of the conductors feeding the transfer switch. 2. The interrupting rating of the protective device. 3. The coordination with other protective devices in the system. The overload protection should be sized to protect the conductors from overcurrents, in accordance with NEC Section 240.4. The interrupting rating of the circuit breaker or fuses must be sufficient to safely interrupt the available fault current at that point in the electrical system. This can be determined through a fault current study, which analyzes the potential magnitude of short-circuit currents at various locations within the system. The overload protection should be coordinated with other protective devices upstream and downstream to ensure selective tripping. Selective tripping means that only the protective device closest to the fault should trip, minimizing disruption to the rest of the electrical system. For example, if a fault occurs on a branch circuit connected to the load side of the transfer switch, a branch circuit breaker should trip before the main breaker protecting the transfer switch. This coordination can be achieved through time current coordination studies, which analyze the tripping characteristics of different protective devices. In addition to providing overload protection, it is essential to ensure that the transfer switch itself is properly rated for the intended application. The transfer switch must be listed and labeled for use in emergency systems, in accordance with NEC Section 700.5. The transfer switch must also be capable of withstanding the available fault current at its terminals. This withstand rating is typically indicated on the transfer switch's nameplate. Furthermore, the transfer switch should be installed in a location that is readily accessible for inspection and maintenance, as required by NEC Section 700.11. The location should also be free from potential hazards such as flooding or excessive dust. The installation of the generator and transfer switch must comply with all applicable requirements of NEC Article 700, which covers emergency systems. This article addresses various aspects of emergency system design and installation, including the sizing of the generator, the wiring methods, and the testing and maintenance requirements. In addition to the NEC requirements, local codes and regulations may also apply to generator installations. It is essential to consult with the local electrical inspector to ensure compliance with all applicable requirements. Proper documentation of the generator and transfer switch installation is also crucial. This documentation should include a single-line diagram of the electrical system, the ratings of all protective devices, and the results of any fault current studies or coordination studies. This documentation will be valuable for future maintenance and troubleshooting. Here are some additional points to consider regarding generator and transfer switch installations. Firstly, ensure that the generator is properly sized to meet the load requirements of the emergency system. The generator should be capable of supplying the total connected load for the duration of the emergency. Secondly, provide adequate ventilation for the generator to prevent overheating. The generator should be installed in a well-ventilated area, and the exhaust fumes should be vented to the outside. Thirdly, install a properly grounded grounding system for the generator and transfer switch. Grounding is essential for safety and to prevent electrical shock hazards. Fourthly, perform regular maintenance on the generator and transfer switch to ensure reliable operation. This maintenance should include inspecting the equipment for damage, testing the operation of the transfer switch, and servicing the generator engine. Fifthly, provide training to personnel on the proper operation of the generator and transfer switch. This training should include instructions on how to start and stop the generator, how to operate the transfer switch, and how to troubleshoot common problems. In summary, installing overload protection ahead of a generator transfer switch is a critical safety requirement. It is essential to comply with NEC Section 700.12 and all other applicable codes and regulations. Proper design, installation, and maintenance of the generator and transfer switch will ensure a safe and reliable emergency power system. When creating an electrical service with a generator and automatic transfer switch, remember that the transfer switch plays a vital role in seamlessly transitioning between utility power and generator power during an outage. However, without proper overload protection, the transfer switch itself becomes vulnerable. Therefore, selecting and installing the correct overload protection device is paramount. The National Electrical Code mandates this protection to prevent damage from short circuits and ground faults. Let's consider the different types of overload protection devices available. Circuit breakers are a common choice, offering the advantage of being resettable after a trip. Fuses, on the other hand, provide a one-time protection and must be replaced after blowing. The selection between circuit breakers and fuses depends on various factors, including the application, cost, and maintenance considerations. When sizing the overload protection device, the ampacity of the conductors feeding the transfer switch is a critical factor. The overload protection device should be sized no larger than the ampacity of the conductors, as specified in NEC Section 240.4. This ensures that the conductors are protected from overheating due to overcurrents. Furthermore, the interrupting rating of the overload protection device must be sufficient to safely interrupt the available fault current at its location in the electrical system. A fault current study can determine the magnitude of the potential short circuit currents at various points in the system. The interrupting rating of the protective device should be equal to or greater than the available fault current. Coordination between different protective devices is also essential to ensure selective tripping. Selective tripping means that only the protective device closest to the fault should trip, minimizing disruption to the rest of the electrical system. Time current coordination studies can analyze the tripping characteristics of different protective devices and ensure proper coordination. In addition to overload protection, the transfer switch itself must be properly rated for the intended application. The transfer switch should be listed and labeled for use in emergency systems and should be capable of withstanding the available fault current at its terminals. The transfer switch should also be installed in a readily accessible location for inspection and maintenance. The generator and transfer switch installation must comply with all applicable requirements of NEC Article 700, which covers emergency systems. This article addresses various aspects of emergency system design and installation, including the sizing of the generator, the wiring methods, and the testing and maintenance requirements. It's important to also consider local codes and regulations, consulting with the local electrical inspector to ensure compliance with all applicable requirements. Proper documentation of the generator and transfer switch installation is also crucial. This documentation should include a single-line diagram of the electrical system, the ratings of all protective devices, and the results of any fault current studies or coordination studies. This documentation will be valuable for future maintenance and troubleshooting. Consider the implications of NEC 700.12, which specifically addresses the need for overload protection for automatic transfer equipment. This requirement underscores the importance of safeguarding the transfer switch from potential damage due to overcurrent. Without this protection, the transfer switch could be severely damaged, leading to equipment failure and potential safety hazards. Therefore, compliance with NEC 700.12 is essential for ensuring the reliable and safe operation of the emergency power system. In addition to the technical aspects of overload protection, it is also important to consider the human factors. Proper training should be provided to personnel on the operation and maintenance of the generator and transfer switch. This training should include instructions on how to start and stop the generator, how to operate the transfer switch, and how to troubleshoot common problems. Regular maintenance should also be performed on the generator and transfer switch to ensure reliable operation. This maintenance should include inspecting the equipment for damage, testing the operation of the transfer switch, and servicing the generator engine. By addressing both the technical and human factors, you can ensure a safe and reliable emergency power system. Therefore, when upgrading an electrical service with a generator and automatic transfer switch, remember to prioritize overload protection for the transfer switch. This protection is essential for preventing damage from short circuits and ground faults and for ensuring the reliable operation of the emergency power system. By following the requirements of NEC 700.12 and all other applicable codes and regulations, you can create a safe and compliant installation. Remember to consult with qualified electrical professionals to ensure that the generator and transfer switch are properly installed and maintained. With proper planning and execution, you can create an emergency power system that provides reliable backup power when it is needed most. Let's further elaborate on the practical implications of this requirement. Firstly, consider the different types of automatic transfer switches available. There are open transition transfer switches, which briefly interrupt power during the transfer process, and closed transition transfer switches, which provide a seamless transfer without any interruption. The type of transfer switch selected will depend on the specific application and the sensitivity of the loads being served. Secondly, consider the location of the transfer switch. The transfer switch should be installed in a location that is readily accessible for inspection and maintenance, and that is protected from environmental hazards such as flooding or excessive dust. Thirdly, consider the wiring methods used to connect the generator, transfer switch, and load centers. The wiring methods must comply with all applicable requirements of the NEC, including the proper sizing of conductors and the use of appropriate conduit and fittings. Fourthly, consider the grounding and bonding of the generator and transfer switch. Proper grounding and bonding are essential for safety and to prevent electrical shock hazards. The generator and transfer switch should be grounded in accordance with NEC Article 250. Fifthly, consider the testing and commissioning of the generator and transfer switch. After the installation is complete, the generator and transfer switch should be thoroughly tested to ensure that they are operating correctly. This testing should include simulating a power outage and verifying that the transfer switch automatically transfers the load to the generator. In addition to these practical considerations, it is also important to be aware of the potential hazards associated with generator and transfer switch installations. One potential hazard is the risk of carbon monoxide poisoning. Generators produce carbon monoxide, which is a deadly gas. Generators should never be operated indoors or in enclosed spaces. Another potential hazard is the risk of electrical shock. Proper grounding and bonding are essential for preventing electrical shock hazards. All electrical work should be performed by qualified personnel who are familiar with the NEC requirements. By understanding the practical implications and potential hazards associated with generator and transfer switch installations, you can ensure a safe and reliable emergency power system. Remember to consult with qualified electrical professionals to ensure that the generator and transfer switch are properly installed and maintained. Also note that NEC 110.3 provides guidance on equipment examination, identification, installation, and use. Equipment that is listed or labeled must be installed and used in accordance with any instructions included in the listing or labeling. Electrical equipment should also be suitable for the specific environment in which it is installed. In summary, providing overload protection for a generator transfer switch is not just a code requirement, it's a vital safety measure. It protects the equipment, prevents potential fires, and ensures the reliable operation of your backup power system during emergencies. Always consult with qualified professionals and adhere to the NEC guidelines to ensure a safe and compliant installation. Remember to keep safety as your utmost priority when dealing with electrical systems.